Now, back to the day the GPS trackers turned on when the cousins hadn't expected it. Because after reviewing prior experiments, here's what they had expected to see.
There's these two camps, it's strong, powerful winds, it's ice, and we were both inclined towards the wind idea. The sharp and carry experiment sure suggested that ice wasn't the driver. Yeah. That was, I have to confess, convincing to me.
The reason Richard is confessing is because the experiment he was referencing was so beautifully convincing that it was not ice. Here's how that experiment went. Scientists put stakes in the ground surrounding a couple rocks, and then one day, one rock moved out and the other one stayed in. The researchers were convinced if sheets of ice were dragging the rocks, then both of the rocks would have moved. So at this point, James and Richard pretty much rule out ice. They're team wind. So they head out to the playa expecting a hurricane to blow the rocks around.
And our expectation was that we would come out here with a 4-season tent. We would stake it down. When it was howling outside, we'd peek out, and we'd see the rocks scooting by kind of thing.
But on a chilly morning with a light breeze, a few days after a snowstorm had brought enough water to make a 3-inch pond on the playa, something happened.
I have an embarrassing thing to say. We saw it like an hour after it happened.
Okay.
But we were unfortunately over there, about a kilometer away, and we saw all the ice that had been a part of this big ice panel piling up out there from the other side. Yep. And it was like, Jim, what's going on? And then we walked along the shoreline over there, and there was big piles of this clinker ice. It kind of goes clink, 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 clink all over the shoreline. That's, plate glass, thin, clear, beautiful glass with rocks in it.
Giant sheets of ice, hundreds of feet across, were starting to move across the playa.
And then we arrived down here. We climbed up on what we call the source hill, because that's where almost all the rocks come from.
Gotcha.
And it was like, oh my God, we missed it. The biggest move event in 10 years, and we were on the wrong, kilometer away. Well, and then it was like the scales fall from your eyes that literally then we understood immediately what was going on.
What they realized was that on rare occasions, when the playa fills with water from rain or snow and is deep enough to form floating ice during exceptionally cold nights, the pond freezes to form thin sheets of ice. The ice then begins to melt in the daytime sun. The ice breaks up, and as the wind picks up, it blows the sheets of ice across the playa and drags the rocks with it. And of course, the rocks drag trails in the ground as they go.
The winds are not strong. I had to kind of hold my hat on.
Yeah.
That wind stress over a couple square kilometer area of floating ice, of course, it causes the ice to move.
Here's why this is all so amazing.
We do know how thick the ice was, and the ice was about 1/8 of an inch thick.
Wow.
Isn't that great?
What Richard and James soon realized was that the corral experiment hadn't disproved the ice theory, it had disproved thick ice.
Move a rock like that with ice that is, thin enough to tear past those stakes. No, that doesn't seem reasonable.
The ice was thinner than anyone thought was possible.
It's thick.
Yeah.
It's this little thin sheet of ice.
That's amazing.
Both start moving, and then they move for 16 minutes with the same exact pattern, but they're 650 feet apart.
Yeah.
And you're going, that's a single panel of ice.
So the wind moves the ice and drags the rocks, and the rocks make the tracks. But here's the thing. The pond isn't big enough to fill the entire playa, and yet...
Some of the rocks do travel all the way over to the distant shoreline.
How do we know?
And you know that they've far traveled because they're this distinctive dolomite.
Okay.
And the only source of dolomite is from there.
Which is just right there. How do they get there?
When you get a pond, the pond forms here. It's almost a flat surface. The pond goes there. It's a classic of what the oceanographers call a seiche event.